Hey everyone, my name is Jeffrey, a program manager here at Microsoft for the Python Data Science and AI Tools in Visual Studio Code team.
Hey everyone, I'm Sid. I'm a program manager on the same team as Jeffrey.
And in this video, we're going to be showcasing to you our brand new Jupyter Notebooks features in the Python extension for Visual Studio Code, and as well how the Azure Machine Learning extension features for machine learning in Visual Studio Code, and as well how you can leverage them yourself to supercharge your own data science workflow. So for this video, we're going to be training a deep learning model to predict and classify pet breeds. And then throughout this project, we're going to be showcasing us developing this pet breed detector all within Visual Studio Code to show you how all the data science features can help you supercharge your work and all the data science features VS Code has to offer as well. So Sid will now be showing you a demo of our final pet detector that we're going to be building in this video deployed to the cloud.
Cool. So as you guys can see, I have a picture of a really cute beagle up in my browser. And what I'm going to do is I'm going to take this image and I'm going to pass it to my model to see whether it can accurately predict what the breed is that this image depicts. So I just copied this last part of this URL. I'm going to now navigate to this tab where you'll see that I have an endpoint that corresponds to my model. And I'm just going to paste this selection from earlier. And so when I hit enter, I'm given a dictionary that includes different sets of pet breeds, as well as the one that the model is most confident about. So that's the beagle breed that you see here. And that's awesome. So the model is able to correctly predict that beagle image, or the breed of the beagle image that I had from before. And so now what I'm going to just show you is a different image so that we can prove that we're not just returning the same dictionary every single time. And so if I navigate to this tab, you'll see that I have a picture of a really grumpy boxer, and I'm going to see whether the model can predict correctly that this image is showing a boxer. So I'm just going to copy this again, go back here, and then paste this, hit enter, and you'll see that the breed that it returns that it's most confident about is the boxer breed. So that's awesome. This model works.
So before we get started, to access the Jupyter Notebooks features from within VS Code, you'll need to first of all install Visual Studio Code, but actually once you have VS Code installed, you'll need the Python extension as well. So to get the Python extension, you can go to the left-hand side and click on the Extensions tab and search for the keyword Python. So here the first result should be the Python extension for Microsoft, and here you can click on Install. I previously installed the extension for the sake of this video, but once you actually have the Python extension installed, you can actually start to open up a Jupyter notebook. So if you have an existing notebook, you can open that up, but if you want to create a new notebook, you can just open up the command palette with the keyboard shortcut Control-Shift-P or Command-Shift-P if you're on a Mac, and search for the command create new blank Jupyter notebook. Clicking on this will open up what we call our notebook editor. And in this, you can see your traditional Jupyter Notebook UI. So you have your cells, your cell actions. You can add cells here. And this basically, the notebook editor combines the flexibility of Jupyter Notebooks as a data science tool, but also combines it with the power of VS Code and the Python extension as a strong Python editor and IDE. So for the pet detector demo, I've already created another Jupyter Notebook. So I've pre-written a lot of the code for this pet detector demo just for the sake of this video. But one of the first steps to creating this pet detector and just many data science tasks in general is to come up with the data set. So for the pet detector, we're going to be using something called the Oxford Pet Dataset. It's a dataset from the University of Oxford and contains around 37 different categories, so different breeds of cats and dogs. And in the first cell, the first step is we're actually going to download this data set onto our machine. So I've pre-written some helper functions to help us do this. So I have this function called fetch and untar, which will actually download this data set and untar it into my local machine. And then finally, here is I have this function which will just organize that data set. So you can see in my images directory, because I've ran this cell previously, it has all the 37 categories of pet breeds in their respective subdirectories. So the first thing we're going to be doing is once you actually have your data set downloaded onto your machine, one of the best things to do first as a data scientist is to actually examine your data set, because you really want to visualize what data you're working with to understand it and to make sure your data is actually sanitized and good. So again, I've written some helper functions to help me do this. So I have some functions which will essentially just get all the images from this directory and put them into a variable, as well as this plotting function, which would just where I use MATLAB plot to actually just visualize what data we're working with. So to actually run the cell, I can either click on this run cell icon up here, which will run the cell, or I can use a Jupyter hotkey. So if I can run this, I can also run the cell using the shortcut Control Enter, and you can see it also runs the cell as well. So we support many Jupyter hotkeys like running cells, deleting cells, moving cells up and down, etc. As well, because we're in the notebook editor and because we're in VS Code, we have also full access to IntelliSense. So in this cell, I want to plot out the different 37 different pet breed categories so we can actually visualize what data we're dealing with. So here I have this function called plot images in grid. So if I want to run, I can write plot images in grid, and you can see as I type, IntelliSense pops up with suggestions. So I want to do this. And then here, because it's a function, it actually tells me what parameters I need. So it takes an images data and number of columns, which I've defined to be how many columns of images I want to show in this graphic. So here I'm going to pass in images data, and then I'm also going to say 6, just this arbitrary number. And again, I can run the cell again with the shortcut Control Enter. And you can see below, after the cell executed, that I can see my matplotlib graph here with 6 columns, and this contains all the different pet breeds I'm working with. So if I wanted to take a closer look at the graph, because the graph is a little bit small, or the other common use cases as a data scientist, if I want to show other people or share this graph with others, I can actually just hover over the graph and you'll see an icon pop up. And this opens up what we call our plot viewer. So in this plot viewer, you can do a lot of things, like you can zoom in on your plot. So these are just images, so it's pretty trivial. But if you had something like a graph and you want to examine, let's say, your x-intercepts or y-intercepts better, then here's one way to do it. And again, the other really cool feature is that you can save or export this, essentially this plot as different formats. So you can save it as like a PNG or JPEG, and then share that image as an email or whatever with others. So if we go back to the original notebook, we can see I've ran this cell previously, and one of the, I guess, challenges, it's a good and bad thing, but one of the challenges with Jupyter Notebooks is because it's so flexible, where you can have cells anywhere you want, you can move cells up and down, you can run cells out of order, you can rerun cells multiple times. One of the common challenges as a data scientist is to keep track of your variables and what your variables are. So to make it easier, we have this new feature called, called the Variable Explorer. So to access it, you can just hover, you can go over the top toolbar and click on the Variable Explorer icon. And here it actually shows all the variables in your notebook that are currently active and what the most up-to-date value is. So here you can see this variable I just created, which is images data, and it tells me some useful parameters, or such as it's a type list, so it's a list type, and it tells me the size of it. So there's 37 corresponding to each of the 37 categories. And you can also take a preview at the value of what this data is. So actually, another example is if I scroll down to my next cell, and here I just run the cell again, and here's where I convert the data into a NumPy array. So you can see as I run the cell, the new variable shows up with images NP. And if I want to take a closer look at my data, there's this button on the right, which is our data viewer button. And if you click on this, it will open up the same data in a Excel-like format in what we call our data viewer. So in this data viewer, you can see all the rows of your data. You can see the columns as well and the headers. And here's another really good way to visualize your data sets. Another feature we have in this is the ability to filter rows. So this is a more trivial example because there's only 37 different categories, but let's say you had thousands or even tens of thousands of rows of data. If you want to filter your data, you can just click on the filter rows button and actually just search for what you want. So let's say I want to ensure that my data set had a pug in it. I can search pug and I can see, oh, there's a row for that. So if I close this back up and go back into our notebook, another cool feature we've added to help with data scientists is something we call run by line. So run by line is a debugging-like experience built for data scientists that will just step through your code line by line, and it's useful to basically see the state of how your code changes. And so another feature I want to showcase is something called run by line. And run by line is essentially a debugging-like experience that we've built for data scientists specifically. And what it will do is it'll essentially just run and step through your code line by line and help you debug or just look through any errors of your code. So let's say I have this code that's trying to convert my images from a NumPy array into a CV2 format. So let's say I want to showcase it or do some image analysis. I can actually run this code first. But I see, oh, there's this error that's saying that expected pointer for argument src, which I might not necessarily know what that means. So here's a really good opportunity where I can use run by line. So I can invoke run by line by clicking the run by line icon in the cell. And you can see it'll stop at the first line in the cell. And here I have the options to either step to the next line or just end this run by line session entirely. But what's really great is this run by line feature is hooked up to our variable explorer actually. So as you step through, you can see as you step through your code, you can see your variables update. So this is really good if you want to see the state of your code, see if it's actually updating correctly. And here, if I'm trying to look for what's causing the error in the cell, I'll just step through the import statements, step through the first real line of code I really want to test, and I can see what image is creating. And it's actually creating a tuple, which is probably what's causing the error. Because this function np_image was expecting essentially an image instead of a tuple. So I realized that this is just a tuple of the image itself and the name. So I want to actually isolate it. So here I can stop the run by line session. I can get the first element, and then I can rerun the cell again. And you can see that OpenCV_image is the new variable I was created, and it looks like it's correct. So we've solved and debugged our code. So the next step to building the pet detector is once we actually have our dataset downloaded, we've extracted our dataset and imported it into our notebook and looked at examined our data to make sure everything looks good, we can start doing the training. So to do the training, we're going to apply transfer learning to train our model. So for transfer learning, we're going to use a pre-existing model called MobileNet, and MobileNet's trained on a bunch of different objects. It's already pre-trained, but we're actually going to retrain the last layer of this model for our pet detector demo. So I have this function or this helper script essentially that does the training for me, and just to clean up this notebook a bit, but you can see here we're passing in MobileNet as our pre-trained model. I point it to the image directory as our dataset. And then some other useful information could be I've set the learning rate arbitrarily at this, and I've set the training steps this as well. So again, I've ran this cell previously for the sake of time, but you can see after I've done the training locally on my machine, we can see I've gotten an accuracy of about 78%, which is pretty good. But just to give you some context, when this dataset, the Oxford Pet dataset, first came out, I think 6 or 7 years ago, the best researchers in the world were only able to get an accuracy of around 59%, and that's with all the compute power they had back then. So you can see how the deep learning and machine learning fields have grown so much in the last few years that I'm able to get, just on a regular laptop, 78% accuracy. And you can also see that this took about 5 minutes and 23 seconds to train on my machine, which I think we can do a lot better, especially this data set's pretty small, and you can see it's because I was running with my local Jupyter server. So if you want to leverage the compute power of a remote machine, we have this feature as well. So to do this, you can just open up the command palette again, so Control-Shift-P, and search for the command specify local remote Jupyter server for connections. So you click on this. By default, it's set to this, which is just using your local machine. But if you have a remote Jupyter server running on the cloud or running on your remote server on-prem or something, you can click on this existing, and here's where you can actually enter your Jupyter server URL. And once you enter it, then it'll actually start connecting to that remote server. And as well, once you're on that remote server, our kernel selector works on our remote servers as well. So if you click on this, you'll see a list of all the kernels in your system. So right now it's local, so it's showing my remote kernels, but if you're on a remote machine, it would show you remote kernels. And here you can quickly switch between your different kernels. Let's say you have another kernel that has a specific package of maybe Plotly that you need, you can switch it there as well.
Great. Thanks, Jeffrey, for showing us how to train your model both locally on your machine and then also on an Azure VM using the remote server capabilities that the Python extension provides. So I know some of you may be thinking, well, what if I don't have a remote server for me to use? Or, what if I wanted to spin up one or many so that I can try running many different training jobs and tweak things like my learning rate, like any other hyperparameters, or even the dataset that I'm using. And then from all of those different runs, well, I want to get the best performing one and I want to use that to then deploy. And so this is where I want to introduce Azure Machine Learning to you. So what is Azure Machine Learning? Just really quickly, it is a cloud service that provides you with a set of tools and capabilities to help you build, train, and deploy your models in a much faster and efficient manner. So now I said a couple of things. I said Azure, I said cloud service, but hold on a second, I'm in VS Code. Does this mean that I need to go and learn an SDK? I need to go and learn a set of command line tools? Or, do I have to leave VS Code now to go to the browser so that I can then manage my Azure resources? Well, this is where I want to introduce the next thing to you, which is the Azure Machine Learning extension in VS Code. If I navigate to this extension tab on the right-hand side, I can search for an extension. I can search for an extension here by typing in machine learning. And the very first thing that shows up is this Azure Machine Learning extension. If I install it, I have a new Azure tab on the left-hand side that I can navigate to. And you'll see here that there is a pane that corresponds to the Azure Machine Learning extension, as well as any other Azure extensions that I have installed. So now, what am I seeing in this machine learning pane? Well, the very first thing that I'm shown is a set of subscriptions that belong to my Azure account. In case you don't have an Azure account, you'll be prompted for a sign-in. And so once you sign in, you can set up a subscription there. If you're an Azure ML familiar or Azure familiar, you'll see that you might have more than one subscription. And if you want to filter it down like I have it here, you can just click this filter icon and you'll get a quick filter that you can then choose your subscriptions from. If I drop down on the subscription node, what I see are a set of machine learning workspaces. So for all of you that are unfamiliar with machine learning workspaces, the best way to think about it is that it is a centralized location slash group of assets and resources that you're going to be using as you build, train, and deploy your models. And for all of you that don't have a workspace here to choose from, well, that's not a problem. The Azure Machine Learning extension provides you with a really easy and streamlined way of creating a workspace by just clicking this button here and then going through a set of quick input options. So the first thing I'm prompted for is a name. So I can call this my demo workspace. I can then choose a subscription that I want to create this workspace in. So I'm going to choose the Python AI and ML tools one. And then I can create a new resource group, or I can select an existing one. You'll see that I'm going to use the search capabilities in the quick picket inputs to find one that I know that I've created before. And then finally, I'm asked to choose a workspace SKU. So in this case, I have two options, basic and enterprise. I won't get into the details of what the differences are between the SKUs, but this information is available to you on the Azure Machine Learning pricing pages. And so I'm also not going to create the workspace just because it does take a while for that for that to get created. So I'm just going to escape here, and instead I'm going to focus on a workspace that I've already created. So you'll see that I have this pet detector workspace. And if I drop down on this workspace node, I'm shown a list of assets and resources that correspond to Azure Machine Learning concepts. Cool. So the first thing that I want to talk to you about when we look at these resources here is something that I touched upon briefly earlier, which is this idea that, I want to run multiple training jobs and I want to evaluate each and every one of those runs. Well, sometimes I also want to have a logical grouping of those, and that's really what the experiments is here. So with the AML extension, I can click down on this experiments node and I can see all of the other experiments that I have defined. So you'll see that here I have a pet detector experiment. However, if I drop down on this, there aren't any runs. Oh, sorry, there is one run that I've completed for this experiment. Now, if I collapse this, I can also choose to create and define a brand new experiment. So I'm going to right click on this experiments node and I'm going to say create experiment. The only thing that I'm prompted for is a name. So in this case, I might just call it the pet detector 2. And I'll hit enter, and you'll see that the AML extension is creating that experiment for me, and voila, it's now in my tree. So you'll see that that was very easy. I didn't have to do much. All I had to do was interact with the tree directly, and through a single click and an input, I have an experiment that's defined that I can now run my training jobs against. Great. So now that I have an experiment to contain all of my different training runs, what I want is a place or is a compute to run my training jobs against. So the way in which I can view existing computes as part of my current workspace is I can click on this training clusters node, and you'll see that I already have a set of computes or training clusters that I've defined. If I want to create a new training cluster, it's simple as just right-clicking on this node and saying create compute. I'm prompted for 2 different compute types, so the AML compute or AKS. In this case, I'm going to choose the AML compute. And then I'm asked to select a VM size. Now, what's neat about this is that I'm presented with a list of VM options as well as their specifications. If I wanted to, I can search for a specific type of VM by just inputting the specifications here, such as, for example, I might want to look for a GPU compute. So I'm going to type GPU, and you'll see that now I have a list of GPU computes to choose from. So for this, I'm going to choose this pretty heavy duty one, which is the NC12. And then I'm going to provide it with a name of NC12 GPU compute. And you'll see that if I input invalid characters here, or I have names that exceed the correct size, then the extension stops me from then creating that compute. So I get feedback directly within VS Code through the extension about whether or not I'm executing these operations correctly. So now I'll just fix this and say I want to create that. You'll see that I have a JSON that's presented to me as the very last step. This just provides me with a set of options that I can change, such as the scale settings, such as the priority of the VM, the node idle time. And for this example, all of these things look good to me. I'm going to use the default options, and I'm just going to hit save and continue. And so now the extension is creating the compute for me, and you'll see that once this compute is created, it will show up in my tree view. So that took a minute, but you'll see that I got a notification that my compute was created, and now I can see my compute here under my training clusters. So now I've defined an experiment, I've created a compute for me to run my experiment against, and so it seems like all of these things are coming together so that I can eventually run a training job on Azure Machine Learning. The next thing that I want to talk to you about is data. So what Jeffrey showed you with the earlier example is data that he downloaded onto his local machine and he used as part of his training. So now many of you may be thinking, well, my data isn't there locally. My data is in the cloud somewhere. It's in some external source. And so what I'd like to say is Azure Machine Learning provides you with a way to reference those external sources in a very easy manner. So there is a data stores node that you can see in the extension tree view that if you drop down gives you a list of data stores that correspond to your workspace. So you'll see that I have these default data stores, and I also have this pet detector file store. If I right click here and I view the data store properties, you'll see that I have information about the storage account that the data store corresponds to, because it is an Azure Blob type data store, as well as the Azure Blob container, as well as the Azure Blob container name. And so for convenience sake, I have those pulled up. So you'll see that this account name corresponds to this storage account name, and then this container name corresponds to this blob container. So now this is an example of a data store that I've created already, but what if I want to create a brand new one that, let's say, instead of pointing to this blob, instead points to this blob storage? Well, that's simple. I can right click on the data store node. I can say register data store. I can give this a name. The other one was called pet detector file store, so I'm going to call this pet detector demo blob. And you'll see I forgot to make all of these underscores, so I'm just going to quickly update that. And then when I hit enter, I'm asked to select data store type. So in this case, so for all of you that are AML familiar, you'll notice that we only support 2 types through the extension today. That's blob storage and file shares. One of the things that we're working on as part of future releases is to support all of the other different types that you love to use. And so I'm going to choose the blob storage type, and I'm going to say that I want to use my default storage account. If I wish to choose a different storage account, I can do so very easily. But for this example, I'm going to choose this default storage account, and I'm going to say that this is in that I want to use this new pet detector blob container that I was talking about earlier. And so again, similar to what you saw with computes, I'm taken to a final JSON where I get a little bit of information as to what is this process that I'm undertaking, hints regarding properties in this JSON itself, as well as read-only settings that I configured earlier. Now, for all of you that are AML familiar, again, you'll notice something very different about what's happening here. It's that the account key information that I'm going to use to authenticate against that data store has already been pulled for me by the extension. This is really cool. This means that I didn't have to go to the Azure portal, search for where the account key is, find the right account key that corresponds to my storage account, and then input it here. The extension took care of all of that for me. So I don't really have to make any changes here. I can just say save and continue. And then what the extension will do is that it will register the data store for me. And once that data store is registered, it will show up in my tree view. And there it is. Awesome. So now with data stores, I've created a pointer or a reference to a blob storage that I had externally, right? So this is data that lives outside of my local machine. Now what if I want to reference data that lives in that blob storage, right? So that I can then use it as part of my training. Well, let's just quickly look at the blob. So not the one that I just created a data store for, but one that I had from earlier. So you'll see that I have this pet detector one, and then if I drop down on these folders, you'll see that I have a zip file that corresponds to the training script that corresponds to the data set that I'm going to be using in my training script. And so now I want to create a reference to the zip file so that I can then get it onto the compute during my experiment. Well, in order for me to do that, I can use what AML provides me, which is data sets. So data sets is a natural evolution of data stores. Think I have a pointer to a data source, and now I want to get a physical reference to the underlying data. Well, it's simple enough for me to just right click and say I want to create a data set. As you'll see that I have one here already, but I'm going to create one for this example. I'm going to call it pet detector file zip2, and I'm going to say that in this case I'm going to create a file data set, and I'm going to choose a file that I have on my local file system. So again, for all of you that are AML familiar, you'll notice that we don't have the use from an existing data store option. That is something that we're going to be including as part of an upcoming release. So that's going to come very soon. But in this case, I'm just going to say that I want to upload a file from my local file system to that data store that I have earlier. So I'm going to choose an arbitrary file here, such as the requirements file that I had. Obviously, you can't use you can, but you probably don't want to use a requirements file as part of your training. Instead, what this might look like is a zip file or a set of files such as a CSV, TSV, Parquet, that you can then use in your training run. And so I'm going to say that I'm going to select this data file, and I'm just going to upload it to not this pet detector blob, but actually the very new one that I created. So I'm going to choose the pet detector blob data store, and then I'm going to provide this with a prefix. So the prefix just tells me what the path is going to be for the data that I'm uploading. This can just look like files or demo. And then you'll see that it's uploading the files to Azure Blob. Once the data set gets created, it'll show up in my tree view, as you can see here, pet detector file zip2. And then if I refresh the Azure Storage extension, what I'll see is that for this blob container, there will be the brand new demo folder, and then within that demo folder there will be the requirements file that I had from earlier. Great, so the Azure Storage extension did refresh properly, and you'll see that I have this demo folder. And then within this demo folder, I will have and within this demo folder, I'll have the other subfolder, and then finally the requirements file. All right, great. So you'll see that the Azure Storage extension did refresh properly, and that I have within this pet detector blob storage, I have the demo folder. And if I drop down on the demo folder, I'll see the requirements.txt file that I just uploaded through the Azure ML extension. And so now I want to recap. I showed you how to define an experiment, which is going to contain all of our different runs. I showed you how to create a new training cluster that we're going to run against. And then finally, data stores and data sets that really encompass all of the data work that you need to do in order to get your data set during training. And so now what I'm going to show you is how to run an experiment through the Azure ML extension. It's very simple. It's as easy as just right-clicking on an experiment node and saying run experiment. So in this case, I'm just going to say that I do want to make that my active experiment because it was the pet detector 2 one that I created from earlier. The first thing that I'm prompted for is a compute target. So I'm going to choose the NC12 GPU compute that we had from earlier. And then I'm going to be prompted with a list of environments. So you can think of an environment as the container in which the experiment is going to run, and it's going to include information about my Python packages, my pip dependencies, my conda dependencies, environment variables, as well as OS level settings. And so Azure Machine Learning does provide us with some default environments or curated environments. In this case, I'm not going to choose any one of these. I'm just going to create one of my own. So I'm going to say create new Azure ML environment, and I'm going to choose a pip requirements file to do that. I have a couple of different options. When I choose the pip requirements file, I'm prompted to select to browse for it. You'll see here that the requirements file shows up for me in the file browser. I'm going to hit open. And then I'm going to choose a script to run. So I'm going to hit enter again. This corresponds to the training script that I'm going to be using as part of the experiment run. And then finally, I'm asked if I want to use a data set as part of my training. And so I'm going to say yes. Now I have to select a data set. So I created the file zip2. That's just a requirements file, not going to be of any use to me. I have a one that I created from earlier, which is the proper training set that I'm going to use. And then the last thing that I'm led to is a JSON, similar to, again, a similar concept to what you saw before, just different, just a different set of details here. So I'm given information about the experiment that I'm running. I'm then given information about the environment that I've defined. So you'll see here that I have this set of pip dependencies, which actually correspond directly to the pip dependencies that I defined in this requirements file. So that looks awesome. And then I have environment variables, which in this case, I'm not going to create any. But the final thing is I have this datasets object, which contains information about what dataset I'm using, how this dataset is going to be attached to the compute. So in this case, it's going to be mounted. And then this script parameter. So you'll see that this is defined as data folder. What does this look like in terms of my training script? Well, that's actually pretty simple. If I go to the training script, you'll see that one of the very first things I do is parse script arguments. And so there is a data folder argument that I'm parsing, and that just corresponds to my dataset directory mounting point. So if this reads data folder, then this needs to read data folder as well. I can change this so long as I change my training script accordingly. And then I can go back to this experiment definition. Again, all of this looks good, so I'm going to say submit experiment. So now what the extension does is that it creates any resources if it needs to. So let's say, for example, you created a compute target, or you created any other resources. It does try and create those resources before it submits the experiment. And now once it's submitting the experiment, you'll see that the experiment will show up as a run under this active pet detector experiment. Great, so you'll see that my experiment is submitted and that my run is starting. So now this is awesome. So I didn't have to leave VS Code at all. I was just using the Azure Machine Learning extension this entire time. And I stitched together a set of resources that I created to run an experiment through Azure Machine Learning. Now, what I'm shown here is the run, is the current run. If I drop down on this, I'm shown logs and outputs for this run as well. And if I drop down on logs, you'll see that I can double click on a log file and stream that log file from directly within the extension. So in this case, this log file is providing information about a Docker image that's being built, and as this log file is being written to, I'm going to get real-time updates, all again from within VS Code using the Azure Machine Learning extension. And so it does take some time it will take some time, sorry, for the environment to be prepared and for the experiment to run. But in the meantime, what Jeffrey's going to talk to you a little bit about is an extension, is how to use the Azure Machine Learning service in a different way so that you can do things like hyperparameter tuning.
So Sid just showed you how we can leverage the Azure Machine Learning extension to create some compute power within Azure to do our training for us in a much more powerful way than our local machine. And if you recall, we had accuracy of our initial pet detector model of around 78%, which is pretty good, but I think we can do a lot better. So to do so, we're going to be leveraging a service called Hyperdrive, and it's also from Azure Machine Learning as well. But what Hyperdrive does is it does hyperparameter tuning on your model to figure out the best hyperparameters that will give you the best accuracy. So what that means is, if you remember our pet detector demo, we had to specify our learning rate, which I picked at an arbitrary value of like 0.0008. But as a data scientist, it's hard to know which learning rate or which hyperparameters will give you the best accuracy. So Hyperdrive takes all of this confusion out for you, or makes this a much easier task by trying to tune the hyperparameter itself. It'll test out a bunch of values for it and tell you which one's the best. So here's the code for the Hyperdrive. And we can see that I'm defining a TF estimator, or TensorFlow estimator, which has our model, essentially. And here below is what we're going to be optimizing over. So I'm telling Hyperdrive that we want to optimize over learning rate, and we're going to pick values between -15 and -3, or sorry, log -15 and -3 as our learning rate. And then the other important part is our early termination policy. So we want our Hyperdrive to be smart. And what this is saying is that if, because Hyperdrive is testing out a bunch of these values in parallel, so a bunch of values of learning rate in parallel to figure out which one has the best accuracy, this is saying that if one of the runs has less than 15% accuracy, validation accuracy, compared to the best overall one we've seen so far, then we might as well kill that job, because that job probably won't get us the best results if we've already seen one that gets even better results, like over 15%. And what's even smarter is that it will, since it kills a job, it will reuse that compute power, recycle that compute for another value of learning rate that it might want to test. And that one might, and then this is how you can save money and save on compute resources as well. So I can run the cell, which will kick off the Hyperdrive job. And again, I've run this. This takes around 20 minutes or so to do, at least for this in this case. And when you run it, it'll give you an ID of the experiment you're running. But again, I've run this previously for the sake of this video. So here I can run the cell, and this is the experiment I ran previously. And the Hyperdrive job actually has a custom IPy widget. So if I run this cell, the custom IPy widget essentially will show me the status of my run. And it'll show me like a graph of the validation accuracies over time and which values of the learning rate got me the best accuracies. So here's the custom IPy widget. And we see, as I've run this previously, a lot of my jobs were completed, and canceled means the accuracy was so low. If we remember, the accuracy was so low that there's no point continuing this job. So we can see that our best accuracy was around 95-96%, which is really, really good. And here you can see like a more visual graph of, here's some samples of like some of the top runs we've seen. And we can see the results. We got accuracy of over 90%, which is really, really good, considering we just put in very minimal work as well. So once we know, once we run our Hyperdrive and job, and we know we've gotten our best hyperparameters, we can actually save that job. So I can run this, and it'll take the best run of the Hyperdrive job and save that model. So here we've saved the model that corresponds to that 90+% accuracy we've gotten. So now that we've trained our model and we've gotten to that over 90% accuracy, I think that's really amazing, by the way. I think we're ready to convert our experimental notebook into production code. So actually, instead of having to go through our notebook, because you can probably tell throughout the slide, we have like a lot of code cells that are just like print statements or assigning variables to random values that we don't actually need to generate the final result. Like a lot of it's just markdown cells as well. We have this really cool new feature called gather, and what gather does is essentially does dependency analysis on your notebook to figure out which code and which cells are required to generate the same output. So it does essentially does the notebook cleaning for you. So here's the gather icon. If I want to find out all the code that was required to just get me the best run or the best run from the hyperdrive, I can just click on this gather icon, and it will create a new notebook with only the cells and code required to generate it. As you can see in this new gather notebook, it only took all the code cells that were required to generate the best possible model. So you can see here's the AML setup, so to connect to AML. Here's the same code that we defined earlier to actually define the hyperdrive job. And then below is actually just retrieving the best model run. And you can also see that essentially it automatically cleaned up the notebook the code I didn't need, things like the print statements, the run progress indicator, we don't have that anymore, and all the markdown cells as well were removed. So it only took the code I needed to generate this cell. Now, once I've gathered the notebook to clean it up, and I want to convert this into a Python script because I want to deploy this, instead of having to go the manual route of having to copy and paste all these cells into a new Python file, we have this new feature called convert and save as Python script. So if you go to the top toolbar, if you click on this button, and it will automatically convert your code to a Python file. So this opens up in what we call our Python interactive window. So you can think of this as a hybrid between the notebook editor, which we saw previously, and just a regular Python file. So within the Python interactive window, you can run cells individually because it knows that it came from that Python file. So you see these run cell buttons. But you can also run the entire file just as a regular Python file. As well, being in the Python interactive window brings debugging to your notebook. So you can see these debug cells. You can set breakpoints here as well, and it'll stop at these breakpoints. It also gives access to all of the Python extensions refactoring tools, so you can extract methods, you can rename variables, you can go to definition, all that good stuff. And it's here where we'll be refactoring our code for the pet detector demo and essentially cleaning up our code so that we can actually deploy it to the cloud as a Python file, because that's what it's going to be expecting. And the end result will be this Python file, which I've created earlier. And you can see this is the same code that we used previously in their notebook, but now it's all parameterized, it's all in really nice functions, and it's all cleaned up. So now Sid will show you how you can easily deploy this pet detector model and our production code to the cloud.
So thanks, Jeffrey, for showing us Hyperdrive and also showing us some of the cool notebook editor capabilities. Now what I want to show you is, once again, the Azure Machine Learning extension, but this time how to use it to deploy deploy models to production. And so what I'm going to do is I'm going to use one of the Hyperdrive runs that Jeffrey did as part of his demo. And so I'm going to navigate to Jeffrey's workspace, which is in the same subscription as I had earlier. And I'm going to find the best performing experiment that he showed through the visualization. So if I remember correctly, that was run 107 for this JMU experiment. So I'm just going to scroll until I find 107, and you'll see that this is a completed run. If I drop down on this run, I can navigate to outputs, and then from outputs, I can find the graph as well as the labels file that I can just right click and then download directly to my machine. So now I've already downloaded the output to my machine, so I'm not going to show it to you here, but what instead I'm going to do is I'm going to then deploy this or register a model from that output, similar to what Jeffrey showed you through the SDK, and then deploy it as an endpoint. So the way that I would do that is just right-clicking on this models node and saying register model. I can then choose a model name. So in this case, I'm going to call this the pet detector model SID. And I'm going to say that I want to use a model file to do that. I'm going to find the model file that I had from earlier, or sorry, the graph file that I want to use, and I'm going to hit open. And then finally, I'm presented with a JSON that just tells me what the model name is, tags that I want to give it, the path of the model, and just a description. So I'm going to say demo as the description, and I'm going to save and continue. And you'll see that the extension is registering the model for me, and that once the model is registered, it will show up in this tree, as you can see right here. And so now I want to take this model and I want to deploy it as an endpoint. The way that I would do that is just right-click on this model and say deploy service from registered model. I can choose a service type. So in this case, I want to use this on-demand Azure container instance. It's great for testing. That's all I'm doing here. I'm not actually doing a production deployment. I'm going to provide it with a service name. So let's call this the pet detector service because, hey, that's what we're building. Let's choose a script to run. So in this case, I'm going to choose the score. I'm going to find the score script, which is in the AML snapshot directory. So that's here. I'm then going to choose a Conda dependency description file. So think like the requirements file. I have a YAML file, which contains all of my dependencies. And then finally, I'm led to this JSON, which provides me with information about the endpoint that I'm going to deploy. So I'm not going to save and continue and deploy the endpoint because it does take some time. But once the endpoint is deployed, I can get properties of that endpoint, get the scoring URI, and then use that scoring URI to get breeds of images that I provided, similar to what I showed you at the beginning of this demo. Thank you.
So awesome. To recap, what we showed you during this demo was Jeffrey showed you the notebook, really cool new notebook editor features in VS Code, and he showed you how he used a lot of those features to help build and train the deep learning model, and then what I showed you was how you can use the Azure Machine Learning extension to harness the power of Azure services. To then, again, assist you with your building, training, and deployment process for the pet detector model. And so what we have up here are links for you to follow. We strongly encourage that you try out both the notebook editor as well as the Azure Machine Learning extension. And if you have any feedback, please feel free to reach out to us directly. We have our emails up there for you to follow up with. Thank you.
Thank you.